Somebody say, hey, 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 hey. Where are my Niger Delta people? Say, hey, 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 hey.
How we've arrived at this research. So it is actually a part of a bigger research that focuses on the changes in both the historical changes and then the future changes in extreme events over the Volta Basin. So this work is actually considering just the future part. And then these are the contributing authors to this work. Now I'll take you through the introduction, methodology, results, conclusion, and then some ongoing research at the Water Research Institute. So now on the background, the first question that comes to mind when one sees the topic is, what are climate extremes? So climate extremes are simply the weather or climate events that go beyond a certain threshold that causes destruction to properties and then eventually lead to loss of life. Example of these events are heavy rainfall that may lead to flooding over certain areas and then also leading to landslides and then mudslides over certain areas. These are examples of flooding that occurred in some major cities around the globe. Now, there are also droughts, that is the absence of water for a very long time that can affect agriculture and then other activities that require water. Now, there's also snow. There are hurricanes, tornadoes, and wildfires in other parts of the globe. In our region, we are mostly impacted by floods, droughts, and heat waves. For instance, some few years ago, and then even recently, last year and then even this year, which I'm sure we may face certain floods. In 2015, extreme rainfall led to flooding, and that flooding coupled with explosion in Accra led to loss of lives and properties in Accra. And this still remains a memorable day, not like memorable in a good way, but a day that we are all going to remember for a very long time when we talk about 3rd June and then the 4th June in Accra. Now, again, we have drought events that also lead to shortage in water supplies that can affect water quality for agriculture and then eventually distorting food security in our region. Now, one other aspect of extreme event that also affects us is heat stroke, heat exhaustion that may lead to fainting, vomiting, and then muscle cramps. So now we also want to look at the importance of the Volta Basin and how future changes of these extremes will impact it. So the Volta Basin provides water resources for transportation of goods and services from one point of the basin to the other. The water in the basin serves as a major source of transportation. Additionally, water resources in the basin are used for agricultural purposes, for irrigation, and then for fishing, serving as source of food and livelihood for a number of people in the basin. So I was talking about the importance of the Volta Basin providing water resources for agriculture, that is for irrigation and then fishing, and then for transportation of goods and people. Additionally, the basin, we have the Akosombo built at the lower part of the basin that provides hydroelectric power to Ghana and other countries, such as Togo and other surrounding countries. Now, for the future, if the future changes in extremes occur, it will affect all these resources. For instance, if there are no enough rainfall, that will fill in the dam at the Akosombo. We all know what led to power rationing in the country about some few years ago, which is still ongoing, partly due to the lack of enough rainfall or water to supply power to the country. Now, when there are also more rainfall, we may experience flooding that will wash away farmlands and then other properties. Therefore, the future changes in these extremes will have a significant impact on the Volta Basin. Now, a question comes to mind. What will therefore be the future changes in extreme events over the Volta Basin? And why do we have to actually know these changes? If we are able to know these changes, it will help us plan effectively and then manage our water resources very well. For instance, if we expect more rains in the future, we will be able to build dams or reservoirs that will store rain that could be used in dry periods when there are no rains for agricultural purposes. Now, in order to look into the future of extreme events, climate models provide a tool to assess this. So we cannot use observational data because the weather we record what we observe. But when we want to go into the future, we look at what we term as climate models that provide the tool for projecting future changes in extreme events. Now, to this effect, there have been works that have looked into the projection of extreme events over Volta Basin and then over other portions of the basin. For instance, Oguntunde Itel says the RCMs, that is regional climate models, in projecting hydrometeorological drought over the Volta Basin. In another study by Aziz, they also used RCM, that is regional climate models, to also project extreme precipitation events over the Black Volta Basin. That is a sub-basin in the Volta Basin. Now, the motivation for this study is actually to look at these extremes over the Volta Basin using the current climate models under the current climate scenarios. That was what motivated us to actually look at the extreme precipitation events over the Volta Basin. Now, we would want to therefore delve a bit into, before we come into the methods used, what are climate models and what are the shared socioeconomic pathways. So now, climate models, simply put, are computer equations or computer codes that try to mimic what the atmosphere or the climate system of the world is showing. That is, it is not actually the observation, but a model that is trying to actually simulate what is observed. In doing so, the climate models solve a number of multiple equations that depict the movement of fluids and then the movement of energy within the climate system. Now, this is a graphical representation of what a climate model looks like. So this is the globe. The globe is divided into grades. So each grade here, for instance, this part represents activities that is ongoing in this one. So we have physical processes in the model where we have snow, where we have rainfall, where we have movement of wind, where we have solar radiation coming in, and then terrestrial radiation is also going out. Where we have ocean current, ocean mixing, and then we could also have vegetation growing on land, evapotranspiration. So all these processes are what the climate models are trying to represent. So these are represented on the globe by grades. So within each grade, we have this process going on. And then the rainfall that is actually recorded in that grade represents all the rainfall values within that grade. So in simple terms, if I have rainfall of say 20 millimeters in this grade box, it is 20 millimeters over all areas of that grade box. So if I'm here, it is still 20. If I'm there, it is 20. If I'm there, it is 20. Until I move to a different grade, that the value will change. So for instance, if you look at West Africa, this is one grade for West Africa, which means every rainfall, every temperature that is recorded here is the same for every part within that grid, unless we move outside the grid. So now we use this setup or these computer equations that solve all these equations, computer codes that solve all these equations to predict what the future projections will be. We could also assess what the past climate has been. In that case, we have observational data we can use to assess the model to see if the model is actually doing well. So the first step in a climate projection is to actually get the appropriate model that can actually simulate what is occurring now. If I have model A, which is able to simulate what is occurring now, I am confident that that model will be able to project the exact, if not the exact, close to the observation, what will happen in the future. So for this work, in order to be able to project the future changes, climate models need to be evaluated so that they can be used for the future changes. Why do we evaluate them? Because if we have errors, that is, the models are not being able to simulate what is occurring now, we have less confidence that it will simulate what will happen exactly in the future. So by doing that, we are able to project accurate or close to accurate climate changes. Now, this is just a summary of what climate models are used for. I'm sure by the end of the presentation, several questions will come and then we can expatiate on that. Now, when climate models are projecting future changes, we have something we call scenarios. That is something possible changes that are likely to occur depending on the pathways that we take. For example, if we are looking at population in the future, if high population goes up, we expect more development, more clearing of forest areas for industry and then for residential areas. That will in turn impact the greenhouse gas we release into the atmosphere. So all these pathways are defined in the future scenarios of the climate. The current one is what we call the shared socio-economic pathways. So there are 5 pathways: SSP1, shared socio-economic pathway 1, SSP2, SSP3, SSP4, and then SSP5. So for each SSP or future scenario, we have something about population, something about the consumption of energy, something about policy, and then other factors that will eventually influence the socio-economic development of the countries within the group. So the in summary, the SSP1 shows that we will take a sustainable path. That is, we will cut down on the use of fossil fuels, and then we will move to more like the green energy. That is what the SSP basically talks about. But the SSP5 is actually looking at where we have taken a path that we focus more on the development of the world based on the use of fossil fuels. The SSP3 and 4 are quite similar in that regard, but these are setting boundaries for economic trade, especially within the SSP3. And then the SSP4 is focused on the development or the prosperity of the elite part, the population in the world. Now the SSP2 is saying that we will just follow the trend we are following now, without any policy, without any implementation of new policies. We are just following the current trend of development, the current trend of use in education, the current trend of technology. So in all this, the SSP assumes the future changes in population, education, energy use, technology over the next century. Now, this is also coupled with ambitions to reduce the emission of greenhouse gas. So the two of these coupled will result in how the greenhouse gases are going to change. So if you're having a lot of population, we're having a lot of industries, a lot of clearing of forest areas leading to low carbon sequestration, and then more release of greenhouse gases. Now in technology, which will also help in adaptation or mitigation purpose. These all coupled to actually influence the greenhouse gases that are released into the atmosphere in the future. So basically, climate models would take one of these pathways to actually assess how the future will be. So in this research, we are looking at the use of the SSP2. That is where we go as the current trend in development is as similar to what we have now. And then the SSP5, where we have actually focused on development of fossil fuels and the use of fossil fuel. So in this case, we're able to look at how, if we are in the middle, how the future would be. And then if we go to the high end of emission, how the future would be. So now the aim of this study is to actually assess future changes in these extremes, precipitation extremes over the Volta Basin, using the current coupled model intercomparison project phase 6 models. Now on the research methods, the study area is the focus of this study was on the Volta Basin. This is the area of the Volta Basin, showing countries that are in the Volta Basin, with major parts of Ghana within the basin, and then Burkina Faso, Togo, Benin, Cote d'Ivoire, and as far north as Mali. So the annual rainfall varies from a minimum within the Sahelian region, the far north of the basin, the Sahelian region of 500 mm to the middle, and then the Guinea Coast area to about 2,100 millimeters of rain. Now, the mean temperature varies from 27 to 36 degrees Celsius. Now, on the models that were used for the future projection of rainfall extremes. So these are the models that were used. And for each model, data period of 2006 to 2100 was used. Now, the selection of these models, as I said earlier within the beginning of the presentation, is based on a study that was published later last year on the performance of about 41 climate models to see whether if they're able to predict or simulate the observed precipitation in it. So out of those 41 models, these were the models that were performing relatively well over the Volta Basin. So the model names, the resolution, the variable that we are considering is rainfall, and then the countries that produce this. So the results that are going to be shown are actually the mean of all these models. That is the ensemble mean of all these models. That is what we are going to show now. Now, for the indices that are considered, what we term as the climate extremes, we are looking for this presentation we are focusing on just 4 climate extremes. So we have the consecutive dry day represented by CDD, which means within the whole year, and of course, this analysis was performed on the annual scale. So within the whole year, we look at the consecutive days, the maximum consecutive days. That is where rainfall is less than 1 millimeter. So if it counts the number of days where rainfall is less than 1 millimeter, the maximum of that is put as the consecutive dry days. Opposite to that is the consecutive wet days, where the rainfall is actually greater or equal to 1 millimeter. Now, we also look at an index which is heavy rainfall, represented by R20 mm. That is any rainfall that is greater than 20 millimeters, it is recorded as very heavy rainfall days over the Volta Basin. Now, we also looked at another extreme, which is extremely wet days, which is actually the 99th, days where precipitation is greater than the 99th percentile of wet days, and it is actually recorded in percentage. So we use these indices as for the precipitation events, extreme events over the Volta Basin, and we want to look at how these will change in the near and then the far future. So now the projection, as I stated earlier, was based on SSP2 and then SSP5. Now the SSP2 has a warming of 4.5, which I would expatiate more maybe when the questions come, and the warming of 8.5 watts per meter square. So all these are possible. The two are possible scenarios within the future where we have medium warming, more like medium forcing of or warming of the atmosphere to a higher warming based on the release of greenhouse gases. Now, the period for the projection is the near future, ranging from 2030 to 2060, and then the far future from 2061 to 2090. Now, we broke that into two so that we could actually look if we can mitigate some actions, take mitigating actions for this period, and then maybe adaptation actions for the next period. Now, the historical period. So all these changes are done in reference to this period, 1985 to 2014. Now, the future changes are analyzed in spatial and then temporal changes. So for this is quite technical, but I'll try it then. For the spatial changes, we are looking at the student t-test. The t-test actually assesses the difference between two means. So for the 30-year period within the near future, the mean of that, and then the 30-year period for the historic, the mean of that, the t-test considers the change within the near future and then puts a significance on it. So that for this study, the significance was at 95% confidence level. So that all changes that fall above this 95, that is a p-value of, say, a p-value of less than 0.05, the change is very significant. The same with the Mann-Candel trends that look at the temporal or the time series of the near and the far future as compared to the historical period. Now, the change signals, that is the changes in the means, are presented in percentage. So straight away for the result, these are the spatial changes in consecutive dry days, that is dry period, over the whole of Volta Basin. So the first row, this and that represents the near future, and then this and that represent the far future. Now, the first columns, this and this represent the SSP2-4.5 warming, and then the second one represents the SSP5-8.5 warming. So the 4.5 has medium warming, while the 8.5 has very high warming. That is high emission of greenhouse gases leading to higher warming. So as we can see for the two scenarios, and then for the two time periods, the near and the far future, we see an increase in consecutive dry days over the Sahelian region and then over the Guinea Coast region, which means the dry periods within the Sahelian region and then over the Guinea Coast region are going to increase for both time periods under both future scenarios. So it is somehow showing that when we have drier periods, like the dry season, for instance, in our area, we are going to have an extended dry season. That is what this one signifies, to about a percentage of 15% relative to the historical period. So if you compare what is happening within the historical period, that is 1985 to 2014, to the future, the near and then the far future, we are expecting an increase of approximately 15% within the consecutive dry days, signifying an extension or the prolonging of drier periods within the area. So this was just for the spatial analysis. Now we look at the temporal analysis, looking at the distribution curves for the historic, which is in the dark color, black, and then for the SSP 4.5 and then SSP 8.5, in blue and then red respectively. For the near and then the far future, as we can simply see, we see a shift to the right for both the near and then the far future, which signifies an increase within the consecutive dry days, and then corroborating the spatial changes of increase within the consecutive dry days over the Volta Basin. We also look at the time series from year zero, that is a 30-year period for the historical period, and then for the near and then the far future period. Now, the black lines, as we can see, represent the historical period, and then the broken blue and then red represents the near and then the far future, respectively. So under this scenario, SSP 4.5 to 4.5 and then SSP 8.5. So the shaded areas are the models used, the four models used, how each model is predicting, and then this is actually showing the range of the model projection, and this is the mean of all the models. So as we can see from the range, we have very high uncertainties or high range for the consecutive dry days for the SSP2 4.5 scenario, and then SSP5 8.5 scenario. But we don't see a very significant increase or decrease within the trend, as the table shows. P-values higher than 0.05 will signify that the change is not as significant as we expect it to be, though there are some increases and decreases projected for the SSP 4.5 and the SSP 8.5 over the Volta Basin compared to the historical period. Now, this is actually done similarly for the other indices over the Volta Basin. So for the consecutive dry, we have an increase in consecutive dry days, which is also translated into a decrease in the consecutive wet days for most part of the Guinea coast and then the Sudano-Sahel and then the Sahelian regions, whilst we have a small increase, which is not significant. So the shaded areas represent areas of significant change, but the increase here is not significant over the Guinea coast, but significant decreases are observed for the near and the far future under both scenarios over the Sudano-Sahel, the Guinea coast, and then the Sahelian region. So this is actually also signifying a reduction in the rainfall periods, the number of times where rainfall is actually going to occur. As we have actually shown in the previous slide, that if consecutive dry days are going up, the consecutive wet days are also coming down. Now, we don't see a marked shift within the distribution, but we see the decrease as a result of the decrease in intensity or the density of the curves, and then spreading out, which means the occurrences of higher frequencies of consecutive wet days are going to be reduced, as shown in the spatial as well. The same for the temporal, the trend analysis. We don't see significant or marked increase or decrease within the consecutive wet days, as shown by p-values greater than 0.05. Now, similarly, we do the same thing for heavy rainfall days, and then we see an increase over some areas over the Guinea, over the Sudano-Sahel and the Sahelian region for the 8.5 far future periods. Then the changes are significant over the Guinea coast and then over some middle portions of the Sudano-Sahelian region. Now, it means that this increase or decrease as seen mainly over the increase as seen over the far future for the SSP5 8.5. The increase in heavy rainfall days. That is, if coupled with the consecutive wet days, we are going to expect less periods of rainfall. But the less periods of rainfall that are going to happen, they are going to be very, very heavy. That is what this is actually implying. Again, there's some sort of reduction in the intensity, but it's spreading and moving and shifting a bit to the right as compared to the historical period. Again, we don't see marked change within the trend analysis. Actually, it's just showing no change at all as compared to the historical period. Now, the interesting part now comes to the very wet periods, where we have rainfall exceeding the 99th percentile, which shows for the near future, it shows for the SSP 4.5 an increase over the whole basin, but significant over some selected areas. And this SSP 8.5 for the near future doesn't show any marked or significant change, although there are decreases and increases at some portion. But for the far future, we see a significant high increase of the wet periods over the almost entire basin, which is actually significant over all regions of the basin, to about 30% change or 30% increase. Now, this signifies that we are, as corroborated by the very heavy rainfall period, the short periods that we are going to have rains, those rains are going to be extreme and then very high in amount. So the small change or not significant change as shown in the spatial changes are actually confirmed by the distribution plot that we don't see actually a marked shift. But compared to the far future, we see a very marked or higher shift to the right. That is an increase within the occurrences of the very or extremely wet periods over the basin. Now, the trend analysis shows an increasing trend for all periods under both SSPs, which is actually confirmed by higher or lower p-values of less than 0.05, except for the near future for the SSP 8.5, that doesn't show any marked significant increase. But for the rest, it is showing an increase in the occurrences of the extremely wet periods over the Volta Basin. Now, in conclusion, the study sought to assess the future changes in extreme precipitation events over the Volta Basin and found that consecutive dry days will increase significantly over the Volta Basin, especially over the Sahel, the Guinea Coast region, about 10% compared to the historical period for both future periods, whereas the consecutive wet days would also decrease over the Volta Basin, especially over the Sahelian and the Guinea Coast region. Now, extremely wet periods will increase significantly over the Volta Basin to about 35% for both near and then far future under both future scenarios. Now, what does this imply? It's showing that consecutive dry periods are going to increase, meaning a little increase may trigger drought, especially over dry seasons over the Sahelian regions, which are already very dry areas over the Volta Basin. While wet periods, though, that have reduced compared to in reference to the consecutive wet days, but the wet period that is extreme wet and then heavy rainfall that are going to increase may lead to floods, especially within wet season over the Volta Basin. Now, the recommendations are that for increases in consecutive dry periods, we may want to consider other or climate-smart agriculture, where we want to look at crops that mature very early or that take short period of time to mature so that they wouldn't be affected by dry or extended dry periods. Now, we are going to have the study projected an increase in wet periods, that is heavy and then very heavy or extremely wet periods. Building water conservation and then water reservoirs to conserve and store water so that it can be used within the dry period is also reasonable, prudent to be considered by people who are actively engaged in agriculture. Now, for disaster, there should be constant flood monitoring, especially over the Guinea Coast areas around Accra, and then areas where a little amount of rainfall causes flooding. Now, the study is projecting a high increase, significant increase in extremely wet and then very heavy rainfall, which means we are expecting more flooding in the near future. Therefore, flood monitoring and the building of large units will help reduce the potential of property destruction and then loss of life. Now, if rainfalls are going to be high and then increase in the near future, coupled with high humidity and other environmental factors, it is likely we are going to have a lot of health issues, especially climate sensitive diseases, malaria, cholera in the near future. Now, some ongoing research at the institute, the Water Research Institute, we are actively engaged in the irrigation systems over the northern region, exploring both the surface river and then surface waters, including river and then streams, and then underground or groundwater resources for irrigation over the northern region. We've also been actively involved in cloud monitoring and then studies within climate sensitive diseases, especially malaria and then other diseases within the Volta Basin. Now, I want to acknowledge the staff of CSIR, then African Suite, for the opportunity provided to study and then present this as well. Then the staff of Meteorology and Climate Science Department within KNUST, and all those who have contributed to this work. And also want to thank the organizers of this seminar for the opportunity given to present. Thank you for the audience.
Thank you very much, Dr. Ajekun, for this interesting results that we are seeing. And we are having indications that we need to really prepare ourselves, reviewing our policies that we have, and then in terms of mitigations plans or adaptations plans that we have in place, we need to really review them. In as much as we are reviewing this, we ourselves within our various community to have to really be aware of these changes and make sure that our day-to-day life activities, especially things that we do that brings about, especially in terms of flood, we decrease those activities and start adapting or bringing in new methods or technologies or systems or attitudes that will help us mitigate this flood. Now, also, if you are talking about seeing drier days, that means dry spell or drought is likely to also increase. So that is also showing that we need to learn how to be conservative in terms of using water resources. We need to learn how to utilize our water. Maybe we need to start encouraging more rain harvesting or water storage within our communities. I think it's been a really interesting presentation and results that you have shared to us. For now, I'm going to pause and then open the floor for questions, for inputs, for maybe clarification. So the floor is open. You are free to raise your hand and I'll call you to speak. In case you will not be able to speak, you can still type in the chat. I'll read the questions out to our speaker or our presenter for all of us to get the feedback. Thank you. So if you have any question, please raise your, I'm seeing one hand, but I can't really see the person. Okay, please unmute and then speak.
Okay, hello, thank you very much. Please, for the presentation, I'm Abdulganiu. So I just wanted some clarification, whether like with what doctor said, do they have any intention of doing a studies on a specific to either the white Volta Basin or the black Volta Basin? I know, even though I know all of them form part of the Volta system, coming all the way from Mali to Burkina. I just a clarification I want to know, because like some activities are happening within that white Volta Basin specific for some people. I'm talking just with respect to our local or the Ghanaian community benefit. Thank you.
All right, thank you. It's Abdul, right? So thank you for the question. That's a very important aspect of the study that this study doesn't actually tackle. But for future research studies, it is a very interesting area to look into. I must say that this study is just based on annual variation. You could also look at the seasonal variations of this extreme and maybe to attempt moving to the monthly, depending on the data availability, to actually look at how these extremes are going to vary within months and then seasons. So as you said, looking into sub-basins like the white, black, and then OT, and then the lower basins of the Volta Basin could actually be interesting as well. So this kind of gives a broader picture of how it is going to look for the entire basin. I mean, looking further into how it is going to be for sub-basin is also going to be very interesting. However, there's one challenge, not like a bigger challenge we can overcome, but GCMs moving to, even for the Volta Basin, looking at global climate models is somehow questionable. It really doesn't, not really doesn't, but it serves as a starting point for the research. Maybe you can also look into the use of regional models, or maybe run our own models for a period of time to actually look at the variations within these sub-basins. Thank you very much, Abdul. Maureen, there's a question
Thank
in
you,
the chat.
Doctor.
Yes, so
Question in the chat.
yes, so that question is coming from Fred,
Right.
Dr. Otulabi. So he says, thanks for a great presentation. Are there any advantages that you foresee from the expected changes in precipitation patterns, and what can be done to maximize these advantages? Is that okay?
Well, yes, it's very okay. Thank you very much, Fred. This is very interesting. Looking at the conclusion of the study, if you are expecting higher rainfall amount and then heavy rainfall amount, besides just planning for flooding, we could especially store water. Based on the recommendation that we can take advantage of the lot of rainfalls we are expecting in the future, very heavy rainfalls we are expecting in the future, to store water, especially over the northern part of the Volta Basin, where rainfall is actually just one season and then not and they have extended dry periods. Storing this water would actually help in all year agriculture activity. In that, if there's water, we can be able to farm throughout the whole year, not just the rain. So I think this is just one part of the advantages. I believe there are several advantages to higher amount of rainfall to agriculture and then to food security as well. I don't know if that's okay.
Hello, my hand is up. I don't know if you can see.
Please go ahead, introduce yourself and speak.
Okay, my name is Dr. Tumbulto, formerly of Research Institute and former director Volta Basin Observatory. I'm currently in Sierra Leone. I want to thank the presenter for the excellent presentation he has made. He's been able to communicate very well. Stake. That's 3 short comments. Number 1, agreement is in the process of carrying out very similar activities. So I don't know whether the authors have been able to, get in touch with agreement or some of their publications on the subject. That's the first question. Now, the second question is a clarification I want to seek. I do understand that the number of consecutive dry days is increasing and that the number of consecutive wet days is decreasing. Yeah. But the actual quantity of water that we are expecting in the Volta Basin, this has been, many models have given contradictory results. I did not quite get what the output is in this respect. Looking at the total, rainfall expected on the Volta Basin, we're going to see total increase. I hope the question is clear. If it's not clear, I can come back again. My last comment relates to the recommendation regarding disaster. Yes, I do agree with the presenter that flood monitoring is necessary. Maybe we should do monitoring and early warning. But talking about building larger drains, I have a concern there because you see, this is a global model that you have used global models. So we are looking at the entire basin. Now, when we are talking of building larger drains, we are talking more of flooding in urban centers. And urban flooding, there are many other factors that come into play, waste disposal, so many, there are so many. So I want to suggest that, you leave out, the construction of large drains. It's important if we were limiting ourselves principally to, see urban drainage and flooding. But as we are looking at flooding within the basin, that may not be appropriate. That's just my opinion. Thank you very much for your excellent presentation.
Thank you very much for your contributions and the inputs. I think.
Hello?
Yeah, Jake?
Yes.
Hello, thank you very much, Dr. Maureen. Sorry, there are questions I need to address. Thank you very much, Doc, for the contribution, especially on the last part on disaster. So as you said, there are several contributing factors to flooding within urban regions. You mentioned waste disposal, even settlement planning, and other portions. So the large drainage system was just an attempt to actually input or some activities that would. So it is not just the large drainage system. It is actually supposed to be the large drainage system, improve settlement planning, proper waste disposal, other activities that will help improve or reduce flooding within urban centers. So as you said, maybe we should focus on more other areas. Now on the clarification on the consecutive dry days and then the amount over the Volta Basin. So this, if I got the question right, this actually doesn't give the amount of rainfall for the consecutive dry period. It is just counting the days. I don't know if that is clear, Doc. So this is counting the days that we have rainfall less than the 1 millimeter. So we are unable to actually sum up all the periods, the amount of rainfall within that period, and then I don't know if I got that question correct. Maybe.
Okay, you got it right. And this
Yeah.
is the thinking I had. I just wanted confirmation. Thank
No,
you.
no, no. So this is just counting the days. It's not just
Yes.
looking at the
Yes.
amount.
Okay.
It's similar. It's similar to the consecutive wet. But if you go to the heavy rainfall, where it's actually recording rainfall greater than, it's even actually recording. Just it is counting the days. But there are other indices I didn't present here that actually look at the amount of rainfall that occurs,
Okay.
the bulk amount, whether it's increasing or decreasing. So there are other indices that look into the amount, but these specific indices are actually looking at the days, not specifically the amount.
Okay.
All right, and then
Good.
on the agreement work, and then maybe future collaboration, I'm very much interested in that. So I don't know if you will be willing to share your email. We can have some further talks on that after the presentation, if you don't mind.
Okay, I don't mind.
Okay.
I don't mind. I can get in touch, and then I have some good friends at Agreement. They will be willing to collaborate with you in such things. Yeah.
That's fine. Great. Thank you.
Good.
All right, thank you very much. So we now have another question in the chats, and that's coming from Ikena in Nigeria. It says, great presentation, Doc. Please, I would like to know the exact models used in this study because you showed us table by Aaron et al. 2016. Did you run all the models? Thanks once again, Ikena.
Okay, hello, Ikena. Thank you very much for the question. So first off, these are just model outputs from the CMIP6 project. So these were not run for the Volta Basin. So they are just model outputs. Now the airing itself is actually just describing the models. So they are similar to that model that were used in that, but this model selection is actually based on a previous study over the Volta Basin by Jacum et al. That actually looked into assessing the performance of about 41 GCMs, the CMIP6 models, in reproducing these indices that have been discussed in the presentation. So these models are not coming from the airing studies. Although airing, so this is just this. Okay, I think the title is confusing. Sorry, I get your point. So these are not from the airing studies. They are actually based on a study conducted by the committee that actually looked into the model performance before they were selected for this future projection. I don't know if that's clear.
So do you have any other question, any contribution, anybody who needs any clarification? So Doc, I think I'll just ask this. I know your studies, you were looking more on the days, not in terms of the amounts, but in terms of maybe in reviewing some of the literatures. Have you found any of the literatures describing the amounts in terms of the amounts in the Volta Basin that if other maybe some past research are showing also decrease or increase in the dry days or the wet days, what is the amounts within the Volta Basin like in terms of the distribution?
Okay, thank you very much, Maureen. So far, I think one research by Professor Fouché, she looked into, it was still days, not the exact amount of rainfall for consecutive dry and then for consecutive wet. She showed also that consecutive dry days are increasing over West, the study was over West Africa. So on the amount, I am not too sure currently whether there are studies, maybe there are studies I'm not aware about that are actually looking into the amount of consecutive dry. I don't know if it sounds right. Even the name is consecutive dry days. Sorry, I'm just thinking aloud. I haven't come across any study. Maybe it's a very interesting area to look into since we are not Maureen.
Thank you for that feedback.
Okay, let me quickly add up to, for instance, if you are looking at indices, looking at heavy rainfall, that is rainfall greater than 20 mm, may vary, but this is like a standard for the definition asked by the expert team on climate change detection and the indices. But we may want to maybe make it specific to certain regions because 20 millimeters over certain regions, for instance, maybe over Axim, which is maybe not over the Volta Basin, but for over Axim, maybe 20 millimeters would be a normal rainfall, not heavy. So looking at the indices in percentile and the ranges is actually able to capture the representation of what is occurring over the specific area of interest. So I just wanted to point out that so that for maybe future research into that, people may want to consider that.
Thank you. But even in your studies, when you were doing, even since the characteristics over the Sahel and then the Guinea coast are slightly different, did you consider that classification in this study, looking at when you were doing the indices?
Yes, that's actually something that came to my side. The differences in rainfall. So if you are saying 20 millimeters is heavy over there, over the Guinea coast, then 20 would be extremely heavy over the Sahelian region. So these are some of the things we might want to consider later for specific indices. We might want to tweak the code to specific area over the basin. I don't know if it's clear. So it is actually something I was considering depending on the specific area of interest. Some indices may be considered very extreme, while others may not even be considered very extreme.
All right, thank you all and thanks everyone. I think we are gradually at the end of today's presentation. I think we have some extra 24 minutes that we have saved for ourselves. And I want to thank everyone. Please, if you have not registered, we'll be glad for you to register. It's all about having your database so that subsequent presentations will be shared with you to join us and for all of us to learn. I also like to use this opportunity to welcome all of us here, especially those who are into meteorological data or hydrological data. Data is becoming a challenge, especially if you want to conduct or go into research. And we know some have ongoing projects. We have instruments installed across the country, but are not, GMET is not fully aware. We just encouraging everybody. We want to collaborate with all of us to be able to enhance data information over the country. So please, if you have any station mounted anywhere or you know of any station mounted anywhere, GMET will be glad for you to share this information. We just want to work together because most of these data sets are being transmitted globally, used to run global models and bring back to us for us to use there, or some of the reanalysis data, some observation data are going in there. We want to see how best we can improve data sets over us, especially Ghana. And I think this can also be replicated over other parts of the continent. So I'm encouraging everyone, feel free, contact us in GMET, and then we will take it from there. So on this note, I would like to wish everybody the very best of the month. And as we enter the new month, keep to your email, watch out for our next presentation. And I promise it's also going to be an interesting one. So on this note, have a blessed day and thank you all for coming. Bye.